Hi students, welcome back to my online class in mathematics. My name is Vishwanath. Today's class is about similarity of triangle, under that applications of maps and models. This is the second class about the maps and models. In last class we studied about maps and model introduction part and a few problems on that. Today we'll continue with the same. So let us have a glance on the important calculation under maps and models. Usually what kind of question they ask in board examination. In last class we studied a few problems. Today we'll continue with the other problem. First thing is about the formula. See, in maps and models actually we have formula, but this formula necessity is not required. The reason is maps and model is about the multiplication and division. With that, unit conversion. See, these are all important operation what we follow in maps and models: multiplication and division and unit conversion, these three. Suppose length of an aeroplane. So length of an aeroplane, suppose length of an aeroplane is given. How to find out its model length? See, first which is given, the length of an aeroplane is given. To be find out its model. So if you want to find out its model, you know that the model length is shorter than the real one. So if you want the model or map, like it is not real, which is decreased by the size conversion, size transformation. So here we need to follow division, because division makes the huge value into smaller segments. So if you want to find out its model length, divide. So what aeroplane length is given, that aeroplane length you divide. So from what we have to divide? Divide from scale factor. Scale factor. Example, usually they give scale factor in 1:2000 like that. So 1:2000 means in model 1 centimeter is equal to in real 2000 centimeters. Meaning in model 1 centimeter, in model if you measure by the scale 1 centimeter, in real one, every 1 centimeter of model length is equal to 2000 centimeter of real one. 2000 centimeter, otherwise 20 meter. So you can convert to meter. So the three important unit conversions are 1 meter is equal to 100 centimeter. This is important. And 1 kilometer is equal to 1000 meter. And 1 kilometer is equal to 1 lakh 10 to the power of 5 centimeter. In every 1 meter 1000 centimeters are there, 100 centimeters are there. In every 1 kilometer 1000 meters are there. In 1 kilometer how many centimeters are there? 10 to the power of 5 centimeters are there. So totally these three conversion, if they ask in reverse, if 1 meter is equal to 100 centimeter, if you want 1 centimeter you want to convert to meter, so 1 meter is equal to 100 centimeter, no, 100 shift here, it become 1 by 100 meter. If you want to convert kilometer to meter, 1000. If meter to kilometer, so 1 meter is equal to 1 by 1000 kilometer. If you convert centimeter to kilometer, 1 centimeter equal to 1 by 1 lakh kilometer. So these six are very important. If you know these three enough, the other three are just reciprocal form. 1 meter equal to 100 centimeter. Every centimeter equal to 100 shift here, 1 by 100 meter. 1 kilometer equal to 1000 meter. 1 meter is equal to 1000 shift here, 1 by 1000 kilometer. 1 kilometer equal to 10 to the power of 5 centimeter. 1 centimeter equal to 10 to the power of 5 shifted here, 1 by 10 to the power of 5 kilometer. With the division or multiplication. If real length is given, if you want to find out model, divide from the scale factor. They will give 1:2000. In that 1:2000 you can divide by 2000. So the real one what is given, that real one divided by 2000 gives you the model length. Suppose the model of an aeroplane area. Model of an aeroplane area is given. Suppose this is given. Model of an aeroplane is given. Its real area to be find out. Model of an aeroplane area is given. Its real one required. So if you want real one, what you have to do? Multiply now. Multiply. So multiplication makes the smaller value 1 into huge value. Model of an aeroplane area is given. You need to get the real one. What you have to do? Multiply. So example, suppose it is 200 centimeter square is given. Suppose it is 200 centimeter square is given. What you have to do? 200 into thus every centimeter makes into 2 scale factor multiplication. 200 centimeter square is the model of an aeroplane area. If you want to get it as its real one, multiply 200 centimeter square already given. Now into what you have to multiply? The scale factor. Suppose scale factor is 1:200. This 200 you have to multiply. This is the scale factor. Scale factor is denoted by small k letter. K is equal to 1:200 given. This 200 you have to multiply. Twice I am multiplying. So 200 you have to multiply once in length case. In area case you have to multiply 200 twice. You are dividing or multiplying the 200 twice you have to multiply. Twice you have to divide in area case. In volume case 200 thrice. 200 thrice divide, thrice multiply. It depends on what you are getting. If you are getting real one, multiply the scale factor. If you are getting model, divide the scale factors. But the scale factor, how many times you are multiplying, how many times you are dividing, that is the case. In a length case, length or height or breadth. In these three cases, these three are unidimension. Length also unidimension, height and breadth. In these three cases, scale factor once you have to multiply or divide. Once you have to multiply or divide. Once you have to multiply to get the real one, once you have to divide to get the model. In length, height and breadth case. They have given area. In area given k value twice. Twice you have to multiply or twice you have to divide. It depends on the real one or the model one you are getting. See, in area case, scale factor k, twice you have to multiply or twice you have to divide. In length, height and breadth case, scale factor once you multiply or once you divide. In volume case, volume is another one. In volume case, you have to multiply thrice or divide thrice. So these three are very important measures to be taken to do the maps and model problems. In length, height and breadth, in these three any one is given, not all the three. Length given, height given or breadth given. In these three any one is given. The scale factor once you have to multiply or divide. In area case, twice you have to multiply or twice you have to divide. In volume case, thrice multiply or thrice divide. So now let us go to one problem that is about the plot. Example problem. On a map drawn to a scale of 1:2000, it's not 2000, 20,000, a rectangular plot of land ABCD as AB equals to 24 centimeter and BC equal to 32 centimeter. First question, calculate the diagonal of the plot in kilometer. The second question, the area of the plot in kilometer square. There are two questions on a map. This is not about model or map, any question. Map means it's not real. like map, model also. Model and map both are not real. That is decreased value of the main one. That is only called as size transformation. On a map drawn to a scale of 1:20,000. So every 1 centimeter on a map, it is actually equal to 20,000 centimeter. Every 1 centimeter on map is equal to 20,000 centimeter really. A rectangular plot. So the plot is in the shape of rectangle, they said. So let us have one rectangular shape. So rectangular, the plot is in the shape of rectangle. It is named as ABCD. Plot is in the shape of rectangle ABCD. In that AB is 24 centimeter given, 24 centimeter, and BC is 32 centimeter. So AB is 24 centimeter, BC 32 centimeter. So these two are given in centimeter. No, so usually the centimeters are comes under the model, map or model. So this is the map problem. In that map problem, ABCD is a rectangular plot, they said, of a land. ABCD has AB 24 and 32. So these two on map. Actually, a real one is AB is not 24 centimeter. Real one is 24 into 20,000. See the length of the. See, this is one of the plot. It is in the shape of rectangle. The rectangular plot length is 24 centimeter. You want to get the real length of the plot. What you have to do? You have to multiply 20,000 for that. So we'll go to the solution part. In that, question is calculate the diagonal of the plot. The diagonal of the plot they are asking. See this diagonal of the plot. Also the diagonal of the plot in kilometer. That means diagonal of the plot in kilometer means they are asking real diagonal. But this diagonal what I marked on the diagram, this is a map. On the map diagonal. So first what we will do, on the map AC how much we will get. First we will get AC how much. As they told, it is a rectangular plot, so it is 90 degree. Every all four vertices are having 90 degree because it is a rectangle. Once we got here 90 degree at B, so this become a right angular triangle. So in that right angled triangle, 24 and 32 given. This is finding is by Pythagoras theorem. We will use Pythagoras theorem. AC square is equal to AB square plus BC square. AB square plus BC square. AB square is 24 square plus 32 square. So 24 square is 576. 32 square is 32 into 32. So 4, 6, 6, 9. So 4, 2, 10. 10, 24. So both we will add 6 plus 4, 0. It is a 8, 9 plus 1 already 0. It is 5, we are 6 and 1. Total we will get 1600. AC equals to square root of 1600. AC equal to 1600, answer is 40. Root 16 value is 4, double zeros converted to 40. So AC equal to 40 centimeter. It is on the map. Understand? So what we got this AC on the map. Actually we want calculate the diagonal of the plot in kilometer they told. Here these two are 24 and 32. Now I got already diagonal, but this diagonal is in 40 centimeter map diagonal. So actually I want the real plot diagonal length. So what I do, AC, that is diagonal. You want to get on the plot is equal to AC diagonal on the plot equals to, actually the diagonal is how much, 40 centimeter. You want it is in kilometer. That means AC on the plot, AC is on the map. On the map, AC is 40 centimeter. Understand? On the map, AC is 40 centimeter. If you want the real one, what you have to do? To get the real one, you need to multiply. What you have to multiply? Here look at scale factor is given, that is 20,000, you have to multiply. How many times I should multiply? Only once, because diagonal is a unidimensional. It is not area. We want just length of AC. Length is a unidimensional, therefore I multiplied once. Then 4 2s are 8. 1, 2, 3, 4, 5 zeros are there. 5 zeros centimeter. See here what unit is there already, that same unit, right? Now you convert to kilometer. So 8 lakh divided by, to get the centimeter to kilometer conversion, what we have to do? Centimeter to kilometer, we have to divide by 1 lakh. So divide by 1 lakh, and this 5 zeros cancelled, we will get 8 kilometer. Once you convert centimeter to kilometer to convert, you have to divide by 1 lakh, then you get 8 kilometers. That means the diagonal length, real diagonal length of the plot is 8 kilometers. This is the first one answer. First one. We'll go to second one. The area of the plot in kilometer square. We'll get area of the plot in kilometer square. That is the second question. Area. Area of the plot in kilometer square. First we will find the area of the map. If you want area of the map, first these two multiply. First area of the map. Area of the map will get, then we will find out the area, because area of the map only not given, but it is still easy. The shape is in rectangle, no? Therefore rectangle area is L into B. So I am getting area of the map, not real one. Area of the map is 24 into 32 because it is in the shape of rectangle. It is in the shape of rectangle. Area of the map is L into B. It is 24 into 32. 24 into 32 multiply. 24 into 32. So it is 8, 4, 12, 7. It is 768. 768 centimeters square. It is the area of the map. Area of the map you got, no? Now area of the real plot. So area of the real plot. Area of the real plot, how to get? Area of the map already you got, centimeter square. So if you want real, understand, to get the real, I need to multiply. Remember, to get real, multiply. To get map or model, divide. I want real, no, so I should multiply. But how many times I should multiply? I am getting area, no, so 2 times I should multiply. What you have to multiply? The scale factor 20,000. Now 2 to the 4, 4 8s are 32, 3 carry, 4 6 are 24, 24 plus 3 27, 2 carry, 4 7s are 28, and it is 30. And how many zeros are there? 1 2 3 4 5 6 7 8. 8 zeros are there. 8 zeros I marked. And it is already in centimeters. See, once you are multiplying, after multiplication, what unit is the same unit right first. Now we will convert to kilometer square. To convert to kilometer square, what I should do? Centimeter to kilometer to convert, 1 lakh I have to divide. But here centimeter square, not 2 times I should divide. 2 times. So 5 zeros, totally 10 zeros. 3, 6, 8, 2 more zeros not cancelling, no? So place the decimal. Then you will get 30.72 kilometer square now, because we have converted centimeter to kilometer by dividing 1 lakh into 1 lakh. 30.72 kilometer square is the area of the real plot. So now after seeing the aeroplane problem, model aeroplane, model ship, and now map problem, let us go to similarity problem once again, because one of the important problem I teach you. One more problem. This is not from applications of maps and model. It is from similarity only. The question is as follows. So this is the problem figure. The question is find the values of x and y. That's it. From the question, find the values of x and y, and A, B, C, D and E, F. AB parallel to CD parallel to EF. These three are parallel now. A, B, C, D and EF, all the three are parallel. Find the values of x and y. In the diagram, what is the value of x and y? To find the value of x and y, first we'll collect the pair of similar triangles. But here how many pair of similar triangles are there? It is difficult to identify, but it is now required to be find out. So what I do, here many triangles are there. Also the name of the triangles are not given. Usually they will prove that triangle ABC similar to triangle DEF, like that they will give. So that time ABC and DEF triangle themselves given. No? So it is easy to equate A equal to D, B equal to E and C equal to F with genuine reasons. But here the name of the triangles are not given. So ourselves we have to choose. How to choose this similar pair of triangles? It is simple. First note down which are the two triangles having at least two angles are equal. Look at ABC triangle and EFC triangle. In these two triangles I am saying. So better I draw those two triangles separately to identify easily. Look at this triangle pair I have taken ABC and EF. With these two lines are parallel. Whether these two triangles are similar or not, let us check. Yes, these two triangles are similar because look at here. These two are vertically opposite angle. As lines are parallel, A equal to F, alternate angle. It is in the shape of Z. So these two are alternate angle. Even B equals to E also alternate angle pair, and this C both are vertically. So this is the one of the similarity pair we got. Let us name triangle ABC similar to triangle ABC similar to what? Before writing the another triangle name, it is a very important thing to be equate A equal to what here? Here A equal to which angle? F angle. That should be placed here properly. Understand? A equal to F, no? So place that. Next letter B. B equal to which letter should come? B equal to E. The third one is C. So therefore, triangle ABC similar to triangle FEC. Why these two triangles are similar? Because angle C equal to angle C, vertically opposite angle. Angle A equal to angle F. These two are alternate angles. Therefore, by AA postulate. Once these two triangles are similar, we go to corresponding sides ratio. How to write corresponding sides ratio? AB by FE. AB by FE equals to next BC by EC, BC by EC, the last two, AC by FC, AC by FC. So we proved the ABC and FEC triangles are similar, as well as we wrote the ratio. Now what are the values given? We will substitute. AB value is 7.5, we will substitute here 7.5. FE value is 4.5. BC value is not X given, and EC value it is 3, and AC and FC values are not given. Just leave it AC by FC only. Now we will cross multiply. As these two are having a single decimal, so this decimal cancels, because in numerator and denominator both are having one decimal places. So without decimal you can write now. Without decimal, or you multiply first 7.5 into 3 by 4.5 equal to x. Only x remains here, the 3 shifted here. 7.5 into 3 by 4.5. Now both are having same decimal places, no? So therefore write without decimal 75 into 3 by 45. Both single decimal cancels. 15 table, 15 3s are 15 5s are. Right. Next 3 cancels, equal to x. Therefore x is equal to 5 centimeter. X is equal to 5 centimeter. We will get answer. One answer we got. How to get y value now? How to get this y value? X value got already. How to get y value? To get y value, another pair of similar triangles we need to select. So you turn this diagram this way. Now you understand. After turning, you will get, look at BPT shape you are getting. No? I am not applying BPT, but the triangle, look at this is the triangle. This BDC and BFE. That triangle I choose now. See this separately, I draw that triangle. Okay, that is the triangle B C D E F. B C D F E F. Here E, here F. Look at this to our parallel. Now this kind of triangles also we solved already. We turn this diagram. After turning, look at BDC triangle and BFE triangle. In BDC triangle, once these two are parallel and D and F angles are corresponding angles. Look at corresponding angles are on the same side of the parallel. Alternate angles are Z shape, but corresponding angles are same side of the transversal. And C equal to E also corresponding angle pair, and D is common. Let us write the names of the triangles here. Triangle BDC. This triangle BDC, no, that is similar to triangle. Before writing the name, first make sure that B equal to what? BDC triangle has B. BFE triangle also has B only, so B repeats, common. Next D plus what angle should come? BDC. This D equal to F, no, so therefore F should come. Then last is E. So BDC equal to BFE. These two are similar. Why? Angle B equal to angle B are common angles, and angle D equal to angle F. Angle D equal to angle F. These two are by corresponding angles. Once these two triangles are similar, now let us go for corresponding sides ratio. That is BD by BF. BD by BF equals to DC by FE. DC by FE, and the last one BC by BE. BC by BE. We will refer the diagram to substitute BD. So from the diagram, BD is not given, BF also not given, BCX and CE, X3, Y 4.5. Here X, here 3, here Y 4.5. We refer the diagram to substitute BD. From the diagram, BD and BF both are not known. DC, from the diagram, DC is Y, and FE is 4.5. BC, from the diagram, BC is X by BE. Understand, BE, not CE. CE is 3, but I want BE. To get BE, what you have to do? X plus 3. BE means it is total, no? So X plus 3. Now Y by 4.5 equal to X value already known. Just now we got X value 5. Here 5 plus 3. Then Y by 4.5 equal to 5 by 8. Cross multiply, Y equal to 5 into 4.5 by 8. 4.5 shifted here. Now we divide. So first we will multiply, because there is no common division. We had to go for a decimal. 5, 20, 22.5. 22.5 by 8. From 8 I divide. 8 2s are 16, 6 carry, 8 2s are 16, 6 carry, 65, 65, therefore 8 8s are 64, 1 will get decimal, 10, so it is 8 1s are, then 2 will get 8 2s are and 5 centimeter, 2.8125. 8 2s are 16, right? So 6 remains, 6.5. So decimal we have to keep here, 2.8125 centimeter. This is the length of Y. So by collecting the pair of similar triangle, first I chose these two, then I took this triangle. One more pair also there. This is the other pair. Look at. So what we selected, the second one, similar type. Look at this is the another pair. FCD FAB, but I didn't select this pair. The reason is in this pair only one pair, that is CD and AB only known. The other FC, AC, FD, BD both are unknown. So only these two known. But in this pair BD, C and BFE. We know this two also and other this two also. Therefore, I selected this triangle. As well as the first one is these two triangles also selected. Reason is 1, 2, 3, 4. 4 values are there. So in which are the two triangle at least 4 values are given, that triangle you need to select. Then only in corresponding sides ratio we could substitute those 4 values for the cross multiplication. If you have only 2 values, you cannot cross multiply with the other one. Still it becomes unknown. So we'll go to today's homework. I give you 2 problems, one from the similarity of triangle, another one from the applications of maps and models. The first one is on a map drawn to a scale of 1:250,000, a triangular plot. Just now I explained about rectangular plot. For you I give you triangular plot of land as AB equal to 3 centimeter, BC equal to 4 centimeter and angle B equals to 90 degree. Calculate first sub question actual length. So these 3 values centimeter, 3 centimeter, 4 centimeter, angle B 90 degree. So these values are from the map of a land. So we want now actual length of AB and BC in kilometer. Actual length of AB and BC find out in kilometer. Actual length you need know, so you go to multiply. This 2,50,000 you multiply with the AB. BC also 4 into 2,50,000 multiply, you will get that. The second question is area of the plot. Find the area of the plot in kilometer square. So first get the area of the map. Area of the map once you get, you'll get. So area of the map is in the shape of triangle, no? Use half into BH. First get the area of the map using half into BH. What answer you get? With that answer, this 2,50,000 twice you have to multiply. Reason is area you are getting. So this is the one question from maps and model. The other question is from similarity I give you. In the given figure, ABC is a right angled triangle. Angle A equals to 90 degree. This is the diagram. In the given diagram, ABC is a right angled triangle. Angle A is 90 degree, as well as their angle D also 90 degree. AD perpendicular to BC is drawn. AD perpendicular to BC is drawn. First question, prove that triangle ADB similar to triangle CDA. Triangle ADB similar to triangle CDA. First equate A equal to CY, D equal to DY and B equal to A. What is the reason? Write the reason as well as by AA or AA postulate. Prove that. If BD equal to 18 centimeter, it is given already in the diagram. CD equal to 8 centimeter. Find AD. Find the length of AD. Third sub question. Find the ratio of triangle. Find the ratio of area of triangle ADB is to area of triangle CDA. And this one big triangle already right angle triangle. In that 2 more right angle triangles are formed as AD perpendicular to BC given. So this kind of triangle in my previous class I explained. See, once it is 90 degree, this is 90 degree, this side also 90 degree, one as linear pair. And also I explained about when in a right angle triangle one more perpendicular is given, what you have to do here, C angle, what you will get, the full C angle equal to A part of A this side, and this B angle will be equal to this side. If C angle here, it becomes X, that X comes here. This B is Y, that Y goes here. So how did you get that one? I gave you by one example by taking values. See, suppose here 20 degrees there. This is already 90 degree, we know that. Here 20 degree, then definitely a 70 degree. 20, 70, 90, 90 plus 90, 180 degree. This is over. Now come to A. At A, complete A is 90 degree. In that this part is 70 means this part definitely 20. 70 plus 20, 90. Now go to this triangle. Here already 90 degrees there. This is 20. Then the third angle is 70. 90, 20, 70. Totally 180. Now check. This 20 equal to this side. This 70 equal to this. On the basis of this example only I marked here. Here by taking values I explained, but you don't give values because we don't know what is the measure of A, C and B. Therefore better you take X, that X goes here, this Y whatever is there, that goes here. So on that ideas now go to prove. A equal to CY. This in ADB. In ADB, A is what? X. In CDA, in CDA, C is what? X. Look at from the diagram, both are equal to X. ADB X, look at ADB triangle, A is X. CDA triangle, C is X. So these two are X. D equal to D, 90 degree. B equal to A, what? ADB triangle, in ADB triangle, B is Y, D is Y. In CDA triangle, A is Y. So these two also equal by Y. You can equate all the three or any two. Then substitute the values in CS for corresponding sides ratio to get the length of AD. Then area you know that by squaring one of the corresponding sides ratio. Hope you got today's class. You try these problems at home. Thank you.